All right, it's Friday, so let's get started. Um, we're going to look at Conway's life simulation today and look at the code for that and I'll give you some time to do the learning active, the discussion post, and so we'll walk through this learning exercise. I just updated this. It used to go to a web page here. Um, and I decided to move this into a Google Doc. Basically, it's the same information, but now if you just now I updated here. I forgot to update this link, but there should be a new link here, and if you open that up, it should open up a Google Doc with that same information. And the reason I thought is that you might want to take some notes or change this. So if you get the Google Doc, you can make a copy of it and work on pasting some stuff in here and working on this Google Doc directly here. So the bells are going today. What? Sometimes when the bells ring, sometimes they just ring at certain times, but these sounds like a special. Sometimes there's a special. I can't think of a. Oh yeah, they usually do a memorial celebration at noon on some days, and they have some things on Wednesdays. So, but this is a Friday, so I would guess it's a memorial celebration for one of the sisters. So that's right. Okay. Um, okay, before we jump into there, I just want to do a couple more things, just so you, when we're done with the life simulation, you are free to go. One, I just want to talk about this assignment this week, the image stacker assignment here. Um, this can be a little bit of a challenging assignment. It requires working with a two-dimensional array, an array of arrays and loops for that. So it's kind of a neat assignment. What we're looking at is images from like a telescope here, and we often get noisy images from these telescopes here. This can be from a variety of factors. Just if this is an Earth-based telescope, we're shooting through the atmosphere, and the atmosphere some adjustment, heat and cool patches, and so that changes the light a little bit, and so each picture will be slightly different there. Sometimes we do this simply because we don't have enough light and we're combining the light together and amplifying it. So if you've ever, did anyone take pictures of the Northern Lights the last couple of days? So if you did that on your phone is basically doing this. It is taking, it should be doing, like, it'll say 3 seconds, or it'll take a 3 or 5 second picture. What really is doing is taking a bunch of pictures because you're moving, and then it's lining them up and then combining them all into one image. And that's why you'll see like a normal picture. You just click and it clicks and it shows up on your screen. On this, you click, it'll go and then it'll just wait a second or two while it does this algorithm basically on this stuff. So that's what it's doing. So again, we're going from these grainy pictures to this sort of picture here. So we've got this now. Let's see if I think I've downloaded this. Maybe I haven't on this computer. So again, you can grab the zip file or the GitHub repo. I'm just going to grab the GitHub repo. It's a little faster for me. Clone this. open it up. Let's see, where is it going to show up here? Yeah, so here's the image stacker here. And again, this is where you want to put your code. Again, we've got a lot of code around this. It brings in the images and does lots of processing with them. So you don't have to worry about that. You just have to worry about this average pixel value code here. And you're given a two-dimensional array of images here. And you want to look at these images of this stuff. So a couple things. So you don't know how many images you have here. So you might have, like you say, you might have 10 images or whatever. So first we grab the number of layers. So the number of images that we're having. So in this, I would be like the number of these fuzzy images we're working with there. And then the number of pixels are the size or the pixel, the number of pixels in each image there. So we have those two values. Now, it's kind of confusing because usually you'd think this is, if we're doing an image, you'd have a two-dimensional array of images, but we've actually tried to simplify this. So we have all the pixels are lined up together in a one-dimensional array. And then the other one is the array of images here. And this is what you're going to do is you're going to make an average image, which is the same number of pixels as all these other images. So we can do a new averages array here. And then we want to loop through and we want to calculate the average of each pixel value here for this stuff and put this in this averages array here. So we're going to loop through each pixel, and then for each pixel here that we want to look up. Now, maybe let's just look at, if like here, I'm printing out the number of pixels here. I can also, I think, print out a particular pixel. So let's print out pixel 5 in image 2 here. So I'm going to say, so I have my images is my array. So I have my images array. The first thing is which image. So let's say I want image 2. And the next value is what pixel I want. I want pixel 5. So if I want pixel 5 in image 2, that would be image 2. Maybe I should write this. I want, image 2 and pixel 5. Because the first thing I want to always specify is the image, and then the next is what pixel it is. So now if I run this, it should pop up. Oh yeah. First it says where do you want to get the images from? I'm going to browse, and I want to go to these NASA images, and there are different ones to choose from. I'm just going to choose one of these folders and choose that, and it'll go and grab all the images in that folder. So here's one of the original images, and then here's the average, and the average is all black because I'm not doing anything right here. And then again, the number of pixels in these images, there's 2 million pixels in each 2.7 million pixels in each image. And in image 2, pixel 1 is this. So again, that's how I can print out a from one image, one of the pixels there. And again, you want to go through each of these. You want to average all of the images and find the average pixel of all like whatever images there are. I think if I look, let's see where. Just wondering how many images there will be. So if I look here, in image stacker and the NASA images. So like here, there are one, two, there are looks like 12 different images of that one, and then some of these other ones won't have that many images. Well, this one has about the same number of images for this. So yeah, this one has 10 images for this. So okay. Again, just remember the process of running this because students always get confused. You run it, it pops up this, you say browse, you go into the NASA images and you pick one of these folders. You just have to click on a folder and say open. Don't open up the folder, just click on the folder and you'll use the images in there. And then you say process and it'll show you the first image. And then it should show you a cleaned up version if you have it working correctly. And mine has no code there, so it's just showing me a blank version there eventually. Okay, questions on the image stacker? Okay. So let's go into Conway's life now and look at that. So I'm going to go into this learning exercise. It pops this up. Conway's life is a simulation that was developed in the 1970s. It was first done on paper, and then, I mean, it's one of those things where once we kind of had computers and could do computer stuff, we were able to discover these very interesting simulations here. There's a whole area of what's called chaos theory where we're looking at complex, well, simple behavior or simple equations that generate complex behaviors here. So you'll see this with certain equations out there, and sometimes you'll see them displayed graphically. So there are some fractals, the Mandelbrot set you probably have seen at some point, where again we have these simple set of equations that we are tweaking at a certain range, so they generate very complex behavior. Conway's life is the same way. We have a set of rules that generate these behaviors for this there. And I get mentioned, so the rules are any live cell with fewer than 2 neighbors dies by underpopulation. So if you have a cell and it doesn't have, it has only 1 neighbor or 0 neighbors, it's going to die. Any cell with 2 or 3 neighbors lives on. And so 2 or 3 neighbors are good. More than 3 neighbors, you die of overpopulation. So anything less than 2 or more than 3, the cell dies. Otherwise, the cell stays there. And then there's a rule for generating new ones. So if a cell has exactly 3 neighbors, then it becomes alive for this. So that's our rules for this. So let's go into here. We want to grab this. Oh, I don't have the zip file here. I thought I put that zip file out there. I'll update that real quick once you get going. So I'm just going to grab the GitHub version here. So I'm going to go here. I got to switch to a non-zipped one. Git clone, paste that in there. Open it up. And I should have life here. Oh. And again, you should be able to run this. And it should, oops, I'm still running image stacker. I'm going to run life there, and it should show some sample images here. It looks like this version actually has a more complicated version. Here, I'm going to delete some of these and just do this original version, which just has these two blinkers here. Okay, so open this up, read through these instructions, answer the questions here. Your goal is to eventually go in this conway.java file, and there's a file called Conway here, and you turn on certain cells here for this. And you can make a pattern, and then you can run the simulation based on that pattern. And then for the discussion area, you'll post your code, your Conway code, and then you'll do a screenshot of what it looks like. So. Okay. Okay, I've updated the instruction. If you like to use the zip file should be linked in there. When I copied it over from the other one, I lost that link. So. And again, once you get kind of the basic questions answered, you want to go through here in the Conway.java program, and in this Conway help, you want to turn on certain values. Just to note, the order of these is kind of what I would call the Y and the X, or the row and the column here are kind of reversed. So this is like 2.1, this is 2.2, this is 2.3 here, and this is 7.1, 7.2, 7.3. So maybe you're thinking, X and then Y. That's what you should be thinking of, is like this is the X and this is the Y here. But and this is how I would write them, but we are writing them the opposite way here. Yeah, I have this written down wrong. We're doing 1,7. That's what it is. 2,7, 3,7 here. So if I wanted to put one right here, that would be at 3,2 there. So again, I can add some more to this. Add one at 3,2, for example, here. Get one right here. And then I can rerun this and get a different pattern for this. So. Okay, so that's your job. And sometimes just adding one cell will be enough to make a much more complicated pattern for this. So you can try out different patterns and add different ones here. So quick thing, if you want to explore this life a little bit more on your own, and just find it interesting, it's kind of hard to program in these exact more complicated features. So if you want to do some more on your own, we have got links here to a couple of things. This is the Calgary users group simulation of life here, and you can clear it, and then you can just draw on here and then evolve it, and it'll go into different patterns there. By default, it runs really fast. I like to slow down, put a little bit of delay in here so it doesn't go quite so fast, but then you can add, so it's a nice simple interface where you can just drag and see the different patterns here and what it produces. And again, there are a lot of other ones online, but and you can kind of see sometimes these things almost seem to move and stuff, and you'll see certain patterns that are like called gliders. Here's one that's just going off the screen here, and it actually this screen circles around, so it's coming back here, and now it's coming over here, and this pattern just keeps moving the way it's set up here. There's a lot of people who have played with this and done lots of stuff. It was kind of like the Minecraft of the 70s and 80s, I would say, where people are building very complex things with this stuff here. So there's this lexicon here where people have built these big things or even smaller things. You can actually click on them and it'll load the pattern in, and you can try out these patterns here in different ways. And so people have like found some of these patterns will repeat after a certain amount. And so people will develop ones that repeat on, every 4 or 5 or 3 updates or whatever. So there are a lot of examples out here of different patterns and what they're doing. So feel free to look through this if you're interested and see what that does. So, okay. And again, for your learning activity, your discussion, you're supposed to post a screenshot of your pattern and then your code, just the Conway code here, so that other people can grab that code and paste it and try it out here. So you're supposed to post your screenshot and your Conway code, and then comment on 2 other people's posts and try out their posts. So grab their Conway code, post it in here, and comment on that also. So that's your job. If you want to work on the image stacker today, feel free to work on that and ask me questions. Otherwise, let me know if you have questions this weekend on this. So, okay.